Hello everyone, today we're going to look at how to prove the cosine rule. With the cosine rule, that we're going to use Pythagoras to help us. If you can remember, Pythagoras is a squared plus b squared equals to c squared. This Pythagoras, it only works for right angle triangle. So we're going to split our triangles into two right angle triangles here. Just before we start, just want to tell you, so this length here is B, this length here is A, the total length here is C, and split them into two triangles here, that we have this side, which is length X, and the remaining side would be C minus X. So if this is X, this must be C minus X. So they add that to C. So let's look at triangle 1. So I have the first right angle triangle is, I'm going to write it in purple. So this part, so this is my triangle 1, and it's a right angled triangle. So let's label our sides. So for triangle 1, I have the longest side, which is opposite, is always going to be C. And I can just call my other two sides A and B. So let's apply. So for A, I have h squared plus b squared, which is x squared, equals to c, which is b squared. Then for my second triangle is here. Again, a right angle triangle, the longest side is C, and I can call this side A and this side B. So let's apply. So my second triangle, I have the longest A, which is again h squared. My B is C minus X squared, equals to my C, which is A squared. It might not look very clear, but we do have a simultaneous equation here which we can solve, because we can remove one variable, which is h squared. So to remove one variable, we use simultaneous equation by subtract the equations. So h squared minus h squared is nothing. X squared minus c minus x squared equals to b squared minus a squared. Now we can expand our brackets. So x squared minus, so remember c minus x squared. So just do it on the side. So c minus x squared is the same as c minus x minus x. Expand your bracket, we get c squared minus cx minus cx plus x squared. So in here we have c squared minus 2cx, so collecting your like terms, plus x squared is equals to b squared minus a squared. Then looking at here, we have x squared minus c squared, so two negatives becomes a plus 2cx, and minus x squared equals to b squared minus a squared. Then simplify it. So x subtract x squared cancels out. So those two cancels out, and we're left with 2cx, then minus c squared equals to b squared minus a squared. Okay, now let's try to make our formula looking like our cosine rule. So if you remember correctly, our cosine rule is a squared equals to b squared plus c squared minus 2bc cos A. So let's try to rearrange formula looking something like this. So firstly, I want to make a squared positive. So that's moving a squared over. Plus a squared equals to b squared. And we want a squared by itself, so we're going to subtract the rest. So a squared is equals to b squared. So this minus c squared becomes plus c squared. And this plus 2cx becomes minus 2cx. Okay, up to this point, this part looks the same, so only this part, now we need to make it look the same. So what does x equals to? So again, we know today we're looking at the cosine rule. So if you remember our trig ratios, which is SOHCAHTOA, and our cosine rule is cos theta is equals to adjacent over hypotenuse. If we consider our triangle 1, so let's just look at our triangle 1. So let's work this out. So if we're looking at our triangle 1, we have label our sides, and we want to find out in terms of angle A. So let's label it. We have hypotenuse, opposite, and adjacent. Therefore, cos A is equals to adjacent, which is x, over hypotenuse, which is b. We want to find out what x is. Rearrange it. We say that x is the same as b cos A. Now substitute this into here. We get a squared equals to b squared plus c squared minus 2c multiplied by b cos A. And now looking the same, so remember when we write it out, we write numbers in front of letters and letters in alphabet order. So this becomes ab squared plus c squared minus 2bc cos